Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Grignard reagents, RMGX, act as nucleophiles and attack electrophilic carbonyl or epoxide carbons. To obtain a tertiary alcohol, the product carbon bearing the OH group must be bonded to 3 carbon substituents. Moving on to the next step. Analyze option B, C2H5CO2CH3, ethyl methyl ester methyl propanoate. An ester reacts with excess Grignard reagent in 2 stages. First equivalent of CH3NGBr attacks the ester carbonyl, displacing OCH3 to form a ketone intermediate, C2H5COH3, methyl ethyl ketone. The ketone intermediate cannot escape the reaction mixture before the second equivalent of CH3NGBr attacks again. Second equivalent of CH3NGBr adds to the ketone, giving after hydrolysis C2H5C, CH3, to OH, which is 2-methyl-2-butanol, a tertiary alcohol. The carbon-bearing OH is bonded to C2H5, CH3, and CH3, 3 carbon groups. Moving on to the next step. A, C2H5ChO, propanol, an aldehyde 1 equivalent of CH3NGBr adds to give C2H5CH, or CH3 after hydrolysis, a secondary alcohol, not tertiary. C, C2H5ChO, propanoic acid. The acidic proton first reacts with CH3NGBr to destroy 1 equivalent, forming CH4 gas. The carboxylate salt formed is unreactive to further Grignard addition under normal conditions, so no clean tertiary alcohol is obtained. D, 2,3-dimethyloxyran, epoxide CH3NGBr opens the epoxide to give a secondary alcohol, CH3CH, of CH3, to type product, not tertiary. And for the final step, only the ester, option B, reacts with 2 equivalents of CH3NGBr to reliably produce a tertiary alcohol. Therefore, the correct answer is B. Therefore, the correct answer is option B.